walk past a bakery. The smell of baking bread hits you, and something strange happens inside your body, something you can't feel. Before a single molecule of carbohydrate has passed your lips, your pancreas has already released a small anticipatory burst of insulin. This isn't a reaction to sugar in your blood because there isn't any yet. It's a reaction to the idea of sugar. This is the cephalic phase insulin response, a physiological echo of a meal that hasn't even begun. Your body is tasting the future. How does your pancreas know? It receives a priority message sent directly from your brain. The sight, smell, and even the thought of food activates sensory neurons. These signals travel to the brainstem, specifically the dorsal vagal complex. Think of this as a command center that, upon receiving credible intelligence of incoming food, uses a dedicated line to alert the troops. That line is the vagus nerve, a massive nerve bundle that wanders from the brain down to your visceral organs. It zaps the beta cells in your pancreas, telling them to deploy the first wave of insulin. But why the rush? Why not just wait for the glucose to actually show up in the bloodstream? Because waiting would be catastrophic. A large, carbohydrate-rich meal can cause a sudden, massive spike in blood glucose, a state known as hyperglycemia, which is toxic to your cells. By releasing insulin early, your body primes the system. It's like opening the floodgates just before the storm hits, rather than after the valley is already flooded. This is a feed-forward mechanism, a predictive strategy, not a simple feedback loop that just cleans up the mess. And insulin isn't the only one showing up to the party early. This cephalic phase is a full-body affair. Your stomach begins to secrete hydrochloric acid, preparing the environment for digestion. The pancreas itself doesn't just release insulin. It also starts producing digestive enzymes like amylase and lipase, ready to break down carbohydrates and fats. Your salivary glands increase production. Essentially, your entire gastrointestinal tract gets a memo from the brain. Get ready, company's coming. What happens if the prediction is wrong? You smell the bakery, your pancreas releases insulin, but you keep walking and don't eat the bread. Does your blood sugar crash? For most people, no. The amount of insulin released in this phase is small, accounting for up to 30% of the total insulin response to a meal, but not enough to cause significant hypoglycemia. Your liver, the great guardian of blood glucose, simply releases a little stored glycogen to compensate for the slight dip. The system is robust. It's designed with a margin of error because, in our evolutionary past, a false alarm was a much safer bet than being unprepared for a real meal. This ancient predictive system evolved in a world of scarcity. Food cues were rare and almost always led to eating. But what about today? You are constantly bombarded with food-like stimuli. Television commercials for pizza, impossibly perfect images of burgers on your social media feed, the smell of Cinnabon wafting through a shopping mall. Each of these is a potential trigger for a cephalic phase response. Scientists are now exploring whether this chronic low-level stimulation of our anticipatory systems could be a contributing factor to metabolic dysregulation and insulin resistance. Your body is constantly getting ready for meals that never arrive. The triggers aren't just external. Your body runs on a clock. If you eat lunch every day at noon, your body learns this pattern. As noon approaches, even without the smell or sight of food, your body can initiate a cephalic phase response simply based on the time of day. This is governed by your circadian rhythms, the internal master clock in your brain's suprachiasmatic nucleus. It synchronizes clocks throughout your body, including in your pancreas, creating a daily rhythm of metabolic preparedness. Your pancreas doesn't just predict the next meal, it predicts the time of the next meal. Ultimately, this reveals a profound truth about your own biology. Your body is not a passive machine that simply reacts to stimuli. It is a predictive engine, constantly updating a model of the world based on prior experience. This is a principle known as Bayesian inference. The smell of bread is new data, which your brain combines with the prior belief that smell of bread usually leads to eating bread to make a prediction and act on it. That little burst of insulin is your body's best guess about the immediate future. It's a physical manifestation of a belief, written in the language of hormones, proving that inside you is a system that has not only a memory, but an imagination.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.